This is, like I said, the third part of a series, and so the saga continues. So this is there will be no models on stage. This is a data modeling discussion. So if you do not want to do data modeling on Cassandra, you're in the wrong place. But don't move, because I like the number. That's good. So I was going to try to beat Adrian on head count, and I don't think I'm going to do it, but I'm close. I'm really close. So we started this whole series together. Well, by show of hands, I guess not all of us, but you'll get there. So with the data model is dead, long live the data model. It was really all about going from the relational modeling world. So my background is I was a relational DBA, a relational developer. I think a lot of you have probably been in the same boat. So how do you get from point A to point B? And so that was really the start. How to get from, I model relational data with multiple tables and normalized data forms. How do I get to my Cassandra data model? That conversation went directly into now that you understand that part, become a supermodeler was really the transition into how to just make really good data models in general with Cassandra. And that general, and by that I say taking just your concept and how do you express that using CQL. And that's a Cassandra query language. And CQL has a lot of features and a lot of things that people probably don't know about. And that was really the point, is to how to do it. And we went through a few examples. So today, we're going to do something a little different. I'm going to recap where we started, but then we're going to have just examples, like real-world examples. And that's where I want to end this thing, because I think everybody learns better with examples. And I know whenever I write code, well, at least all the Perl I ever wrote, I copied somebody else's code and just made some modifications. So, and bash scripts, right? There was only one dude that ever wrote a bash script. The rest of it's just copied it. So, same with Perl. Michael, are you in here? I'm sorry, that's the truth. Yeah, mister, I wrote a Perl driver for Cassandra. I'm going to copy it, and then I'm going to make my modification. So, we're just going to go through a few little topics to catch everybody up, because, we got to. So why does data modeling matter? And so I've said this before. I just said it this morning to Pankaj, my friend. I said, Cassandra lives closer to your application. And so this is really where the data model is much more important with Cassandra. Because if it's living close to your application, there's no generalizations. And it makes you think a little differently about how you deploy your applications. So we always talk about, well, Cassandra has a right use case. Yes, it does have a right use case. I was an Oracle DBA. What did I want to do? And Pankaj, I'm going to go back to use you as an example. We'll just use it for everything. And because it was what we had. But then it didn't work out for a lot of things. I want to do multiple data centers or things like that. I love memcache. I use a lot of memcache, but that doesn't work for everything. So we've gotten to this point. Polyglot persistence is where we're at now. It's 2013. We store our data differently for our different applications and for different use cases. So when we do that, we have the opportunity to really screw it up or make it cool. So I've seen this 100 times. I work with customers all the time. I go out and talk to people, and I see the wrong data model, or I see the right data model. So the right data model, winning. And the wrong data model, there's a sad panda. So let's not be sad pandas. This is what we're trying to do, right? We're trying to do the right thing. And there doesn't need to be any sad pandas out there. Then again, we don't need a lot of Charlie Sheens out there either. That would probably be a bad idea. Was it tiger blood? So see how I'm on time. Next. All right. So when to use Cassandra, and this is the nutshell version. And I put in little tiny text here. It's real tiny. It's about that big. These are ors, not ands. Here's a few bullets. And I think you probably heard this enough, but I'm just going to reiterate. For the rest of the review crew here, we need to be more than one data center. That's a requirement. OK. Well, if you have multi-master, active-active, what other choices are you going to have? That eliminates a lot of choices. So how about the scaling problem? I used to spend tons and tons of time trying to figure out performance and capacity planning. And what did that mean? Well, that means that somebody's got to give me an accurate number well, this is how many users we're going to have. Okay, as an engineer, what did I do? I just times 10. So, and then, all right, I'll get a call HP or Dell and say, I want the biggest box you got. And that was capacity planning. Well, when you really have no clue, or you're really not wanting to put that into the problem domain, Cassandra's a good choice because it scales so well when you need it. So the other thing that I hear is I need this maximum uptime. And what's funny is I feel like people have been lying for so long about uptime because I did it too. Maintenance time doesn't count on your uptime. Oh no, that was planned maintenance. Of course it was down. Well, what do you mean? You were down. Your customers couldn't get to your website. Well, yeah, but that was planned. Okay. So what did that mean? Oh, you probably had to do it like 3 a.m. on Sunday, and that was exciting. So getting out of that world is awesome. And so getting closer to 100% uptime, there you go. Cassandra is a very good choice for that. So we also have the problem of money, because let's just face it, we go to the VP of finance and say, yeah, we need an unlimited amount of money to this application because it's going to be cool. What is that going to be? No. So we have to think about dollars. And so when we want to do scaling or we want to do multiple data centers, how is that going to play out money-wise? I bought a lot of Oracle in my day, and when I used Golden Gate, that just quadrupled the price. And that sometimes made it so, well, I guess we're just going to have to deal with it. It's in one data center. OK. And even then, it wasn't that good of a solution. So it just makes sense economically. And then the final thing. That's why we're here, right? We got to get the data model right. And I work with a lot of you on just this topic, and I've seen so many good apps out there. I've left places where there's just going to be some good stuff happening because the data model was just perfect. So here we go. What we're going to do today, we're going to go through 4 real-world examples. Real-world meaning I get to see it all the time. And we're going to try to go through those. It's not going to be a deep dive into the application. Let's face it, we got an hour here. I'm going to be crunched to try to get that much time in. I want to leave some time at the end for questions and answers because I know you have a lot. Just quick disclosure, I'm going to be over there after my talk. So you can come up and talk to me. Let's just try to, but keep in mind, everybody has questions. I know that. Well, I'll try to get through them as quickly as possible, but I'm not going to be able to dig through your app with you just today. But there's plenty of time left in the year, so we can figure it out. So we're going to go through the use case. Basically, it's just here's what they were trying to do, here's what they're trying to accomplish, and then how we did that. Now, I'm going to make sure and make this point. If you see this data model up there and say, dude, that's me, you're giving away my company secrets. No, I'm not. No, I see these all the time. So I'm not giving away anybody. And in the case of where I was close, I probably anonymized it some, and I blended a couple too. So don't worry, you're not going to pop up here. Maybe a little bit, but not a lot. So all these examples are in CQL3. We don't do any thrift on these, but CQL3 makes this a lot easier for us to explain. So I'm going to express the data models in CQL3. It's going to be a lot easier because it is a very elegant way to describe a data model. Here's exactly how you're going to store your data. And there's some caveats with that we'll go through real quick. But wait, it's a trap. Yeah, so yeah, here's the one we hear a lot. CQL doesn't do dynamic wide rows. That's why I'm using thrift, dude. Come on, CQL is lame. No, it's not. It can't. So this is probably the thing that we all need to just get over if you don't believe it. And so we say there's some terminology changes. I know, as from the community, this has really been kind of an interesting transition. And, it's moving from one house to another. But trust me, we're getting there together, and I'm seeing a lot of help on this. So if you've never heard of thrift or you've never used it, then this isn't a problem. But I know where we are. We have some people in this world and some in that world. It does do the wide rows, meaning that you can have lots and lots of columns. And when I tell people that, they're like, but this is a fixed schema. No, really. And Jonathan did this really great blog post. I really suggest everyone read it. It was written out of frustration, I'm sure, but we just really needed to get this into a clear, concise thing. And then if you go read it, you'll see my almost equally as long response to somebody's comment, which has even more information on it. So I'm sorry, I kind of doubled the size of that blog post. But that is a really good read if you're really just want to get your head around it. And more importantly, if you want to get into what's going on behind the scenes. How is the data being stored? Even though I'm seeing it on the screen as like rows and columns, what's really happening behind the scenes? It will help you. And we're going to look at some of these models here. So, can't put my hand in my pocket. My friend Rebecca said I put my hand in my pocket too much, so I'm not going to do that anymore. It's like saying with your pocket. First data model, shopping cart. It's not yours. It's somebody else's. So I put on here, because customers giving you money is a good thing for uptime, right? Because that's true. You don't want your shopping cart to go offline. So here was a use case. We want to be able to store it reliably, meaning that it's when someone says, I want to buy something, it goes in there and stays there. And we want to eliminate downtime, because if that's not available, we're not making money. Again, let's go back to what the point here is. We're making money on our website. So multiple data centers. Really, if you're chasing uptime and you're in one data center, really, you're faking it. You're not doing it right. So the other thing is the Cyber Monday problem. And I hear, everyone has a type of problem like that. Not everybody, but it doesn't have to be Cyber Monday. You may not be selling anything. Black Friday, Cyber Monday. You may have another thing. When I worked at Hobson's, it was, students would show up at the last second for everything. Okay, that's our Cyber Monday problem. It's just the thundering herd, or whatever analogy you want to use. But that problem is hard, because you can never predict how screwed up people are. And people are just really, they're the best load testing tool, because you will never, ever, ever figure out how they're going to act until they do it. So be ready for that. So what we're trying to avoid here, and what has been the problem in this one, is that for every minute you're offline, you're losing money. And that's really not OK. And so that was kind of the driver here. And speed. That was the thing that Amazon did a couple of years back. My history is in web performance. That was one of the things we were chasing, is the fact that for every millisecond or 10 milliseconds of latency on your web app, Amazon calculated they were losing $1 million. Now, granted, that's because they were making billions, but come on. That's money, and they're losing it because people are pissed off that they couldn't get to the next page. So let's fix that, too. So here is my whiteboard. Those of you who have gone through my whiteboard discussions before, kind of looks familiar, doesn't it? So here's my whiteboard. So my plan is that each customer is going to have one or more shopping carts. That's right, we're going to have something really cool. They can have 2 or 3 or 4 shopping carts. And we're going to denormalize that data so that we can get it fast. Denormalizing meaning putting all that data into the same row. So when I ask for a shopping cart, I get all of the information back. So one shopping cart equals one partition, or that's a row on the storage side. So that means we're going to get isolation, row-level isolation. I'm not going to go through row-level isolation, but if you go back a couple of my webinars, I talk about it some. And that's really how you make sure you have consistent data on a single row. So then each new item is going to be a column. So, see, I got a laser pointer. So as the cart goes in, I'm going to have this partition key, which is a row key underneath in the storage engine, of a username with a cart ID, and then this wide row that's just all these items, and it's going to be who knows how big. But that's cool, right? Because what if somebody wants 103 items? Great. How about 200? Great. 5? Well, you got to work. I have another data model to get them to 6, but we're going to try to make it so that it's flexible. So whenever someone puts random amounts of data in there, great, let's do it. So and I really love this big screen, because last year I was on a smaller screen, and everything that I put up was micro. I watched the people in the back almost fall out of their chairs. They're like, what is that? So this is huge. So what I do, I have a couple of tables here. So I have my user table up here. Whoops, back. There. I have my user table at the top here. that is just going to, that's just our normal user where it's, you know, an entity where we have a username and a first name and last name. But part of this is I have a set. Now, part 2 of my webinar, we went into collections. And collections are really a useful tool in CQL because they give you some dynamic portion, but they keep you on the same row. You can denormalize data really effectively, but also put that random element on top of it. And so using a set, list, or map, you can do some things like that. Now, I use them quite a bit just because I like that flexibility. But I think you'll see that they do have some really interesting uses. So what I'm doing here is I'm just storing a set of shopping carts. So if one user has 3, 10, 100, it's fine. They can have that many. And so whenever someone logs into our website, again, thinking about this from an application level, someone logs into our website, they get a list of their shopping carts as part of the result set. Then, whenever I want to display those, I have those already. I can go get the varchar is going to be storing that particular shopping cart. So what I'm going to do at this point is that I have a shopping cart table. And there's a couple of things that I'm doing here that are kind of interesting. So again, it's going to be by username. Who are they? The cart name. And then I'm going to start having these item IDs down here. Now, these two things right here are going to make up my partition key. So that's that part right here that I created when I created my primary key. That's basically one row. So one user, one cart, one row. Awesome. The item ID makes it so that it partitions into a wider format, and it'll put it all on one row. So whenever I put in new items, like up here. So here's my one storage row, one partition. So I have, this is me, and I have a shopping cart called Gadgets I Want. And then here's the actual item that I want to put in there. And then if you notice, I've created a map here at the end for dynamic information. And that's, again, I said I use it a lot, but it's effective. I'm going to use that map part down here to put in these random stuff like related information or volume discounts, just things that are applicable to that particular item. So when someone goes to my website and they click on their shopping cart, I'm going to be able to get all the items out. So I have all of this information in one pull, and it will be one row. So it's going to be pretty fast. So let's go back to the way our data is fast in Cassandra, row lookup for speed, and then we do that slice, or in this case, looking at a full partition for the efficiency. This keeps us all in one node. It's very quick. We're talking about milliseconds of access time here. So this is great. We're satisfying a couple of things here. It's going to be fast for our users, so they're not going to walk away. The other thing is that this is going to work really well in a multi-data center model. It's not over multiple rows. It's on one row, but it's Cassandra. And Cassandra just does multi-data center perfectly. So that's my shopping cart data model. See how I'm doing with time here. Awesome. User activity tracking. Now, I'm not going to go into a full-blown data science thing here. We got people that do that all the time. What I want to do this is get into more of where the rubber meets the road, the actual use case, where people are using that data. If you go to Strata, you'll hear about all these cool things that people are going, oh yeah, we got this guy who's got a PhD in statistics who figured out, if I have this one user, they'll click on something. And then if they click on that, they'll buy 3 more of these things. And that was awesome. Well, that's not what we're trying to accomplish here. What we're trying to do is find action with that. We can watch our users. So we want to react to that in real time. As users are doing things on our website, and I know we've all seen this before. It's a little creepy whenever things happen like that. You're going on a website, or you're like on Amazon or Google or something like that, and you click on something, and all of a sudden things start popping up that seem a little related, and you're like, oh, I do want that. Well, that's part of what's going on behind the scenes, but you need to be able to react to that in real time. If they came back to you, say, an hour later and said, wait, I think you might have wanted something else. Too late, I'm gone, dude. So that's where the real-time component comes in, right? So we have all these application pods that need to be supported. And a pod in an application sense is that they'd be in different data centers or maybe in different racks, but they need to be spread out all over the place. And it could be that we have different applications themselves that are watching activities that could be cross-talking to each other. There's plenty of companies that have multiple properties underneath one umbrella, so you get the crosstalk between those. And the scale, I mean, I think that's going to be always a good reason. So the bad part of this is that the company in question was having a hard time because they were losing those moments. They knew that they had actionable items that were going through, and they were missing them. And there's nothing worse than leaving money on the table. So in that case, they needed to be quick on this. And Hadoop is just too long. Now, Hadoop can create models and do things very well. But in this case, they needed to be right on it, milliseconds, and they needed to be ready to go. So here's our whiteboard again. I love whiteboarding. So here's the kind of like a high-level diagram of what it would be. So here's our dude who's on our website. And as they were walking through our website, we're making decisions. And we have this interaction decision algorithm. That's algorithm, not algebra. So that's going to be making those decisions, but they have to have input. Now, see, Hadoop or data science is really good for feeding up or figuring out those models, but then it comes down to you need to have data to put into the function machine, input and output. And that's a little harder sometimes. So what are you going to do with that data? And sometimes it's not just one thing. It may be a course of action, maybe 4 or 5 things. So I'm getting feedback from my website all the time. Now, keep in mind that we're trying to do this at speed, velocity. How much are we trying to do this? OK, if I have a lot of people on Cyber Monday all clicking on my website and I'm trying to get page lift, then we're probably talking thousands or hundreds of thousands of clicks per second. So we need to be ready for that. So every interaction point, so as they go through the system, is being stored in a table. And that's where all that speed's going to come from. The long-term interaction, we're going to break that out into a separate table. Now, here's the concept. And if you've had me in your office whiteboarding in front of you, you've probably heard me say this 100 times. Do not be afraid to write to multiple tables. Cassandra loves writes. So if you got to do 5, 10, 100 tables per interaction, awesome. It'll do it. No problem. Got that. And what does that mean? That means you're going to be ready for the read or whenever you need that data. So do that. So in this case, I have this requirement. I want a really short table. I'm going to show you how I do this. But I'm going to have one table for that. And I'm going to have a longer table for that longer interaction. Like I want to store it out later. And that gives me some options. Then I'm going to use Hadoop on that longer table. But that means that the data that's hot, that's fast, I'm just going to dump it. Yeah, that's right. I'm going to get rid of data. And that's kind of a cardinal sin in data science, but I'm going to do it. So the other thing is I want to use a reverse series. And you've probably seen me do this a lot. And I'm going to show you why this really makes sense. It's about speed. We want to be as fast as possible on the database. So here's my data model. The data models, I'm going to have these 2 user activity tables. One of them is hot, and one of them is more of a long tail table. And really, the biggest difference is how I'm storing that data in them. So the first one, all right, class, we remember this one, don't we? Reverse order is kind of one of my secret weapons. It's not secret. It's just a great weapon. Reverse ordering, again, means that as I'm storing data, so I have my user activity table. Here's my person, the time that it happened, and then some activity codes with some details. But look at my primary key. The row partition is going to be the username, and then I'm going to have my columns all part of an interaction time. So that means I'm storing this really dynamic row of data, columns going like crazy, all with timestamps on them until it falls off the stage like I'm about to. But I don't want to look up data over there. I want to look at the last thing that happened. So I'm going to reverse that, meaning that I'm going to have all my time series data reversed naturally for me, And I see some people nodding their head because they've seen me do this before. It's cool, right? But that means that when I say I want the last 10 things that happened, you're looking at the last 10 things on that storage row. You're not iterating over 100,000 items or 10,000 items to go to the end. That's just not efficient. So we're just going to store it in that reverse format. On the longer tail table, I'm going to put the interaction date. So now I'm going to partition the rows themselves so every day has all the interactions for users. This is going to make it easier for me to later when I want to run Hadoop, where I can create a Hadoop job that will iterate over all those rows per day. If I wanted to do a range of days, it's just an easier query to do. But it's just formatted in a better way. And I'm not reversing it. I'm just going to keep it in its natural order, which is fine because whenever I iterate, again, like with Pig or Hive, it doesn't really matter. I'm going to be iterating over a lot of data anyway. So let's just keep it like this. So what I'm doing whenever I'm inserting my data into user activity is you'll notice right here, using this TTL, I'm going to expire that data after 30 days. I just want to have 30 days worth of data in that one table. The other table doesn't have that. It's just going to be forever, and that's cool. Now, bonus, it's not up here, but I'm going to tell you, is another thing you could do is your column family, you could name that with a different name. You could put the month in there or a quarter or something like that. So if you actually did want to keep your column families separated or just wanted to use that as a way to separate your data, you could do that. And so that's just an option in there, but really this 30-day expiring. Now, again, with TTLs, you get a delete for free, pretty much. That means, when we run a delete on Oracle or even MySQL, would you run a delete in the middle of production day if you had to, say, delete 1 million rows in Oracle? No. The first thing you get is a phone call from the DBAs telling you you're crazy. But it's just going to create a lot of redo logs. This is a great solution to that. How many batch jobs have we all written called cleanup? Yeah. So this is going to really help out, right? Because now you're going to have this idea of, your data is going to be gone after 30 days. Now keep in mind, there's no kill switch. This is going to happen. It's really hard to undo this. So make sure when you use a TTL that you're using it the way you want to. It's not, I'm going to make it disappear. No, wait, I don't want to. It's really hard to undo that. So just make sure that's what you want in your data model. So now, how am I going to use my data when I have this now? So this is where that reverse really helps things out. So up here, I have my select from user activity limit 5. By doing that, I'm only getting the first 5 items. Great. Very efficient. But what I got here was I got this whole thing right here like, OK, so I logged in. I went into my gadgets I want. I deleted it. And then I created one called anniversary gifts. And I went to jewelry. Oh, man, the decision engine's on. Man, OK, it's time to go. Man. Let's put some flowers in front of this guy. I don't know, maybe a trip to Cabo. Where are you, Chad? All right. So you were going to really use that information effectively. So this is kind of a funny example. But you could think of some really creepy things you could do with this, which is cool. And that's actually what's being done in the real world. This decision engine is really based on the interaction, what's going on. And storing just a few of those items can really give you some interesting insight or some actionable items for your application. All right, now, how are we doing on time? I want to make sure we have plenty of time for questions. All right, we're good. Log collection. This is where I came to Cassandra. I had a lot of logs. And I think a lot of people find themselves here because of the way that Cassandra stores data. So there's 2 problems, right? Log collection, it means that something is spitting out a lot of logs, and it's never just one at a time, small bits. No, it's tons. It comes like in a torrent. There's amazing amounts of data out there that are created now from machines. So we have to have something to keep up with it. So the high-speed logging part, that was a requirement in this particular application. So we also needed to have our Cassandra nodes near where the logs are being generated. And now if we were in multiple data centers with our applications, we want to make sure that Cassandra nodes are right there too. We don't want them to go across data center. Last thing I want is a bunch of bandwidth bills of all this data just getting streamed all over the place. I want Cassandra to manage the replication in a more efficient way, but make sure that the applications just connect to those local Cassandra nodes. That's one of the big ones. And then I also have this requirement where I need to kind of pre-dice my data. Now this is even better example of what I was talking about earlier about writing to a lot of tables. And I've advocated this so many times with the rest of you, and I'm going to really drive this home, is why, I hope. But that was one of the requirements, because we have dashboards. What do dashboards do other than make C-level people happy? Why else? But I mean, there's like a lot of things on there. Ooh, it's pretty. But they have some use. I've been to the Etsy office, and they have this wall of plasma, and it's just a bunch of graphs on there, and people look at them. Sometimes there's meaning in it, but that kind of stuff requires you need to have speed, because a graph from yesterday is pretty boring, and it really isn't going to give you any idea what's going on today. So the bad side of this is that the scale, and this actually happened to me, I just couldn't get enough scale out of my relational database for some of the logging that needed to be done. If I denormalized my data, for one thing, then it hurt the ingestion speed. I couldn't index anything. It just turned into a big problem. And of course, I've said this many times before, my Oracle box would scale right up until I ran out of money. And when you're storing logs, it's really hard to get a lot of money for that, because it's hard to say, well, this is worth $1 million of Exadata. No, it isn't. All right. So that was one of the really big problems to get around. And so the batch analysis, too, it's just too late. Batch is batch. Batch has a lot of use. Don't get me wrong. I love doing data science on a lot of data. But when you need a dashboard, you fire up a Hive job, it's over. You lost everyone's attention span. And the people looking at it, they have a short one. So here's our whiteboard. So I'm going to use Flume in this case. You can use other things like Storm. Scribe is another one. This is Flume because I have a lot of experience with Flume. And Flume's job is to collect a lot of logs, like a log Flume. And I'm going to use that Flume connection point to create a sink, which is Flume terminology, to dice up my data. So I'm going to take my raw logs here as they come in, say it's from my web app or something like that, and I'm just going to do 3 things with it in this particular case. Now, I could do a lot more, and I probably should, but in this case, I'm going to do a raw log, a latest success, and a latest fail. Just really short bits of data that I can get that out from. And then, so with my raw logs, I can just do a lookup. That's one use case from the same data point. And then with my successes, I'm going to throw those up into my nice fancy graphs over here for eye candy later. Awesome. So I'm really taking that one data point and I'm doing multiple things with it. Really cool. It's kind of like recycling. But this data model is not that hard. It's just kind of a concept thinker. You got to really put your mind in the look. You have to look from it from where is going to be the consumer. Ingesting this many is not hard. Cassandra can keep up with this. It's now we need to think about our application from the reader's point of view. So I have my 3 tables here. The log lookup is pretty boring, but that's OK, because I'm going to have a lot of other things going on. So the log lookup is just, I'm going to have a source. So I have my source, my date. So I'm going to be storing each row is going to be 1 minute of data, because let's face it, those logs can come in milliseconds. So we have date up to the minute. So by using this compounding here, we have a source and a date to the minute as a row key, and then just timestamps. And that's just going to create how many columns we need. And just keep going, keep going, keep going. So the other thing I'm going to do here is I'm just going to store the raw log, and I'm going to gzip that. And that's a really good idea. I've seen this with a good effect in a lot of places where if you just have like some JSON or XML, God help you, zip it. It takes a few microseconds in Java to run it through a compressor, and then it just saves so much on wire speed. If you're putting a 2K block of text over the wire at 10,000 per second, it's going to add up. But you can probably crunch that down by 50% or more, and all you're saving is wire time. And that's good. And let's face it, when you do a lookup like this, you can then reverse this and say, give me all the logs from this source and this time, this time period, and then pull it back in and deserialize or decompress it at that point. That's an application concept that works pretty well. But our other two here are much cooler. So now we're actually going to get into some interesting uses of counters. Now, counters have good uses and bad uses. In this case, I'm going to say this is a good use case because what we're trying to do is just create numbers that will be graphed for people looking for eye candy. So in the login successes here, we're going to have this source and date up to the minute again. So we're going to do this as the same type of key, except in this case, we're not compounding it. So we're just going to be marking these sources and date up to the minute and then marking each one of these so we get counts. So that means that from a counter standpoint, and I'll show you the code how to do it, that means it's going to be incrementing a counter in that minute. So if I have 10 things that happen in that minute, it'll be the count of 10. 100, 100, that sort of thing. But that way I can say how many things happened over these many minutes, and I'll get multiple counts. I'm also, because I love it, I'm going to reverse this so I can ask, what are the last 10 things that happened, last 10 minutes of things that happened? So I've created two tables here. If you notice, I've created a login success and a login failure. I'm really busting out this. I'm dicing this data way out here, but that's great because now if I want to graph login successes and login failures, different tables, different calls, but it's very efficient because I just pretty much created this massive materialized view very fast. And as things are happening up to the millisecond, I'm getting access to it on all my dashboards or whatever graph I want to use or something like that. So this is going to make my logging a lot more effective. There. So this is what I'm going to do with that. I actually created some data. So we have this one simple select command. And this is really what we've done, the beauty of what we've done here. When we ingested that data and diced it up, it made it so we have this opportunity now to create this really stupid, simple select. And that's not going to be very long to run. That's going to be a few milliseconds to run. And what I get out of it is I say, give me the last 20 minutes, because I know everything's in there for a minute. So I get this nice graph of data. And if I hit refresh, I'm going to get up to the minute on everything. Now, if I want to change that to something like milliseconds or whatever, that's fine. And the counters are going to be counting along in the background. So notice that there was this little window here. I'm going to put this in as an example, because this is where log data sometimes is really important. And I know, Eddie, I know you're in here, and Splunk is awesome, but this is a cool use case too, okay? You have these 2 minutes where something bad happened with your logins. Well, if you knew about that tomorrow because you ran it in batch, then you're just going to be scratching your heads. So this is where this kind of usage, in use case, really makes sense. It's like, whoa, something bad happened. Uh-oh, yeah, that logins failed, and then it's better now. Or maybe we were able to do some action with it. So, but this is that high flight data. All right, I think that's enough on that. All right. Adam, are you in here, man? Raise your hand. All right, baby. I figured it out. Yeah, sorry, bud. So user form versioning. And now this is, I'm calling out Adam because he's the one who made me think about this even more. It is really a use case that I've found a lot of places. And so here's the problem that we're dealing with, is that we want to store the version of a form indefinitely. And we just want to have a very efficient way of doing this so that we have version 1, 2, 3, 4, how many versions there are. We want to scale to any number of users, and that's always a requirement. We want unlimited scaling, and because we're going to have 1 million users, just like Facebook. And we want to be able to commit and roll back our data. If I make a mistake on version 2, I want to go back to version 1. And if I say I want version 2 to be my gold version, it's going to turn into the right form. Cool. So I've tried to do this before in a relational database, and it's not easy. I mean, it's a lot of tables that have to be joined. And so it wasn't a very easy model there. It's just not an easy model anywhere, really. But in this case, I think this will work really well with the way that rows and columns work in Cassandra. We also have this need where it needs to be all over the place. We have our local data center, which is where most of our data is, but we also have cloud components, like some of it's in Amazon or some of it's in Rackspace. So it needs to live in both places, and that's really difficult, especially if you're trying to create like a homogeneous persistence layer where it's maybe the same technology. It's not always easy to go from one to the other whenever you're doing local and cloud, especially if you want to try to get them to synchronize in any way, and you want to have them replicating. So these are some of our bads. So here's how it's going to work. Our whiteboard session says we're going to have this partition key, a row, which is going to be a username and a form ID, but I'm going to store these blocks of those form attributes for each time they make a version change. And so I'm just going to keep growing that out as, you know, random amount of times. If we have somebody who's a real busybody on a weekend and they create 10 versions, fine. I'm not going to have to deal with that in any other way than just my data model will maintain it. We also want to separate the tables to have, we have the data that they're working on, and we want to have some stuff that's live on the production site. So we're going to have these two things going on. So that's an easy requirement. The exclusive lock. Now, I hate saying the word lock. It's not so much as an exclusive lock for a computer, which is a different problem. It's more of just making sure someone doesn't stomp on somebody else. Now, it's funny because I've had this discussion with somebody else about why don't we just teach all our users how to use Git? Okay. Yeah. Okay. Yeah, so we're going to get a lot of admins in like HR to start using Git. No, that ain't going to happen. So let's think about this a little more in their domain. How about a web page? Just whenever you go to look at a form, you can see who's currently editing it. There you go. That's good enough. I mean, can you imagine somebody doing a cherry pick on a form in HR? No, it's not going to happen. All right, so here's our data model. So we're going to have a working version, which is more or less just how that's going to be where all the activity is going to be happening. So we have the username and the form ID, which is going to make up the row key. We have a version number, which is going to make all those rows. We're going to have a locked by. And then one of my favorite collection items, the map back here, is going to have all those different attributes, the form attributes that I'm going to be using for this particular form ID. So that means that if I change any of this, that I'm going to increment the number in my application, and it's going to store the form in its entirety. So that in each form can be different. And so that gives us a lot of flexibility. And why not? Because I like to do it every time anyway. It's kind of like becoming my boring trick, but it's very effective. Reversing that so that the last form that I was using is the first thing on the stack, more or less. So whenever I want to get the latest version, I know that it's right there. I don't have to iterate over a bunch of stuff. That's just really, in general, a very efficient pattern with Cassandra. So we have our first version that goes in the system. It's going to look like this. So I have my own little coding scheme here where I'm going to have a text box called first name, and here's the name of it. Here's the display name, and here's what's going to happen with the HTML. So this is my first version. So when I do that and I create that, that's version 1. So I'm going to lock this. I'm going to edit it again. So that just means I'm going to put a username inside that table. So whenever I go to edit that table, one insert puts the username in there. So if other users come in to use it, you can read that and say, is it blank or is there somebody there? Oh, there's somebody there. OK, well, I'm going to go back and display to the user. Oh, user P. McFadin is using that form right now. OK, I can't touch it. That's a lot easier than Git. And I think for our use case, it'll be fine. Now, if you want to modify that a little, that's completely possible. I'd love to talk about all of these models probably have variations that I would love to talk about. These are meant to be somewhat simplistic so we can get through it in an hour, but there's lots of variations in here. And I know that you probably have some really cool ideas, and I want to hear them. So we have this version number that is locked. So whenever I finish it, and I say, here, I'm done, I got my form finished up, I'm just going to put a null in here whenever I increment it to the next version. So that pretty much releases the lock. So the next person that comes along is going to read that, and it's going to be empty, and they'll be fine. Now, this is all happening at speed across data centers, my local data center, my cloud. It's all there. Very easily replicated data. That's it. So you got 4 models out of this. And I hope that what you can get out of this is just some ideas. That's what these are all about. I haven't given you the full picture, but hopefully I've given you something that you can work with. I get asked all the time, and I'm pretty happy to hear, I mean, not for my own personal edification, but that I hear people say, oh, I watched your video on data modeling. Good. Use resources. I do these webinars and these modeling sessions so that it can help you. Because when I first started with Cassandra, I had so much trouble with data modeling. I mean, I was trying to shoehorn my relational model, and it was just horrible. I know this is a need, so I figured it out, and this is a community. I'm going to try to help you figure this out. And so you can do this. This is very doable. So that means that yours is next. And I want you to think about what you're doing right now. And I know a lot of you are working on projects right now and things that you're doing currently, because I've talked to you. But try out a few things. And really, iteration is the key here. There's a lot of different ways to do these. So try different ways to do them. See how they work. And if it doesn't work one way and you really get frustrated, find us. We're out there. The community is out there. Engage an expert. I'm not that hidden, if you've noticed. I'm kind of obvious. Come out and find me. And Twitter. If you follow me on Twitter, I talk about data modeling and Cassandra topics all the time. And you can use it like an RSS feed if you want. And I've had a lot of people contact me about data modeling, and as much as I can do in 144 characters, I can help you. But sometimes it turns into a larger discussion. That is the point I'm trying to make, is engage people. I really hate to hear how people tried a project with Cassandra and failed because they couldn't get their data model to work when they didn't even ask. So ask. People are here to help. I mean, look at all the green shirts we have in this room. Raise your hand if you got a green shirt on. Oh, yeah. So that's good for you. All right, that is all I had. I think we can do some questions. So here's the rules on questions. I'm not going to rewrite your app. But if you have general questions about why did you do this or how did this work, you can go ahead, let's ask those questions. But if it's going to take I need to know all about your application, let's try not to go that far. So where's our mic? Man, there's a lot of hands up. We're going to play lottery. Let's just start over here, and then we'll walk away across.
So when you do multiple writes, you're replicating your data to multiple locations. And obviously there's bugs in your code and you're going to make mistakes. You're going to write it incorrectly to one location and maybe do another. Is there processes or tools or concepts that have emerged to help make sure that you haven't hosed yourself by as you write that data to multiple locations? Because writing bug-free code is not an option.
All right, so if you're in a position where you're writing code and you're deploying new code into your cluster, and you have the potential of writing bad data. Essentially, that's what you're talking about, right?
Yeah.
That is probably the reason, number one, why you do a backup on Cassandra. It's not because you're going to lose your data. It's because somebody hosed it for you. And that happens all the time. So in this case, snapshot is your friend. I always tell people before you do a code push, do a snapshot. And a snapshot is literally that. It's a point in time. So if you're going to do a snapshot right before the code push, and then all of a sudden your code deletes a bunch of email addresses, right on, Pankaj, you remember that, don't you? All right, so I'm going to point out, it wasn't his fault, by the way. But it's going to happen. And then you can use that snapshot to get your data back. And there's a lot of options with that, but just first and foremost, do the snapshot. It's almost free on the file system. It's a hard link. Over here.
Hey, Patrick.
Hey, there we go. I knew you were going to ask a question. OK, go ahead.
How rigid should your model be if you're going to be using Solar for a lot of searches and stuff?
The Solar question. So Solar brings out a whole new thing, and really you probably want to think more of your data in terms of your Solar schema than Cassandra if you're using it for just Solar. If there's a blend, then you have to think about that. But keep in mind that if you're overlaying Solar on top of Cassandra, the Solar schema is fixed. Here's what you have. You can put dynamic fields in, but really it is fixing the schema in some way. So there's a little different way of doing that, and probably more of a deep dive about your application. But in general, that's how you would handle it. All right, one more over here.
Hi. On the last example you gave, there is an update you were doing, and that's a read before write. So it normally says that you try to avoid those. And so what is the basically a general rule of thumb where you were OK to do read before write and where you're not?
Yeah, I know. I knew I was going to get that again. Oh, I broke the rules. No, the read before the write is really about, you don't want to do a lot of those. Like if you're doing read, write, read, write, read, write. In this case, I'm doing one read to see if there's anybody there. And it's user-based. So if I click on a link, I get a read, and then I'm going to make a fork action on it. I'm either going to move to the next form, or I'm going to give them a different form, saying it's blocked right now. So it's not in the application. I'm not reading and writing it like one after the other. I'm doing a read, and then if there's something going on in the application that then will result in a write. So I mean, that's, I guess, my cheesy way of saying I'm not doing a read before a write. Not in the way that we wouldn't want you to do it, which is right after the other in the same block of code.
I had two small questions. So first, do you think, I saw you didn't list secondary index as example. Do you think it's less important than expiring column or exclusive log in your examples?
You're talking about secondary indexes. Why didn't I use them? All right, so in my second webinar, I think it was, I talk a little bit about secondary indexes. I feel like secondary indexes are a crutch for relational folks because they think it's speed. Secondary indexes are built for convenience and not for speed. And I try to avoid them in general just because there's a lot of confusion. But if there was a case where you did need it, I would call it out. In this case, I didn't have any. And I think you'll find that if you do your data model correctly from an application standpoint, the need for secondary indexes is very minimal. I mean, there's always a case for something, right? But I feel that means it's a very small case in this.
The second question is, someone said Thrift is better to help you form the habit of Cassandra. Do you think that's one of the reasons it's better than the CQL?
Thrift is better for what?
Form the habit of using Cassandra instead of the regular traditional SQL syntax.
Yeah, that's what I hear too. I would suggest reading that blog post. It's not like that. And I think there's just a lot of people that have been using Thrift, and I was one of them. It took a while for me to get my head shifted around and understanding it. But it really, in that blog post, and if you read my comment on it, it's really about understanding what's going on in the storage engine. What's really going on here? CQL is abstraction. It's a way to make it look better for the user and for the application. The storage engine hasn't changed that much. There's some different things going on, but not that much. It's still doing the right thing, but it's forming it's giving you the correct path to get to that right thing. So that's why I advocate it all the time. You're going to have a better data model. Yeah.
Thank you.
Yeah, can you talk about limitations on collection sizes, if any? And
yes.
In your lock model there, just curious, what happens when two people ask if it's locked or not at the same time?
I knew I was going to get that one too. So you never put a lockup. That's why I said, oh no, I put a lockup there. Because then you always get the lock guys. You know, oh, wait a minute. So the first question, collections do have practical limits. And the reason that there's a practical limit is because you have to deserialize them. So that can cause a performance hit. I talked about this in one of my other webinars where it's really about where you're at with your performance. If you're looking for the most performance, a serialization is not something you need to take lightly. So if you put, say, 100,000 things in there or 10 things in there, there's going to be a different cost, right? I believe there's actually a hard limit of 65,000 right now. I don't know if there's anybody from a Cassandra core? I think that's what it was, 65,000 right now. But then again, you probably don't want to put that many in there anyway. It's not a substitute for a good data model. It's an augmentation. All right. Second question. How do I manage that lock? I don't have a good answer for that. I mean, there's collisions that can happen. At that point, if you're really that worried about those collisions, and what I would probably say is that you can then create a different model where you put a timestamp along with the user. You can create a locking table. And then that way, if you do have 2 people in there at the same time, you're going to see that there are 2. And so you just augment that row or that column value so that you have a little more information in there. Say a timestamp is really good. So that if you do have 2 in there, then you can flag that as a problem. It's all about the knowledge that there's an issue. Yeah. Mm-hmm. What's that? Check and set. All right, so yeah, I'm not going to talk about 2.0 features. I'm talking about what you can do today. But yeah, check and set is really the way to do that. And thank you, Cassandra core developers, because you're going to make my life a lot easier. Yes?
So in your user activity table, you had 4 or 5 columns plus a clustering column. So every insert will write essentially 5 columns to the storage engine. Is there a concern of the table getting far too wide above the typical 10,000 columns or 20,000 columns that's considered, safe for Cassandra?
Which table was that? Let's see, oh, you mean the initial one? Well, it was date to the minute. So it only stored up to the minute of that data. So there would only be 1 minute's worth of data in that one column family, or in that one row. So if you were collecting logs, say, every millisecond, that's going to be a lot, yeah. I mean, in general, what I look at from the width of the column is more about the volume of data that's in there and not the count. Because what you're trying to avoid in this case is incremental compaction. So we're really getting into the weeds now. So the incremental compaction that I try to avoid is, say, like that 64 meg limit on a mem table. Now, you can make that bigger if you wanted to keep that from happening. But in general, that's what I look at. Now, if that's going to be a problem, in this case, let's change that to every 100 millisecond bucket or something like that. You tune that. There are some teams probably in here that I've worked with where we've done that, where we've modulated that row key so that we can get a different column based on what you're trying to accomplish. If you don't mind having an incremental compaction because it's not really an impact on your system, fine, let's have 300,000 or 500,000 or 2 million columns. But if that's more of a concern because of performance later, or you don't have the I/O to take it, then okay, let's figure this out. That's the try things and then measure, do it again, and this is how we do our development. More. I saw a bunch of hands.
Yeah. Again, on that same table, there was a clause in there with, I think it was with clustering order by.
Right.
And you had the timestamp in there.
Right.
I clearly don't understand how that's working because it seems like you'd have all of the same timestamps together. And if you're looking it up by user and timestamp, that you'd want it clustered by user and timestamp.
Okay, so this guy, right?
Yes.
Date to minute.
I think we're close.
Oh, user interaction, okay. All right, hold on.
Back a little farther.
Back. This one.
Yes.
All right, okay, great. Yeah, so the row key, that one partition of data is going to be the username. And then every column is going to be a time UUI.
Ah, okay, clustered within the row.
Right.
Ah, okay.
So
yeah,
then,
I'm thinking relationally, so sorry.
That's okay, we'll beat it out of you. As a community, we do that as a service, right? No, it's fine, because that's where you think about what your application needs. I really wanted that in some sort of laid out format, and this is one of the great use cases for Cassandra, is that temporal data. Probably the go-to move for a lot of people, and then unfortunately I hear a lot of people say, well, it's only good for, no, it isn't. But thinking about, wow, that's perfect, because now I have this one row that I'm looking up of a source, And I need that data over a certain range. Like with time, it makes perfect sense. Because what do you always do with time data? You say, oh, give me the last 10 minutes, or give me 3 days worth, or something like that. So yeah, putting those in individual columns does one seek on the disk. That's what we want. Very fast. More. Oh, hi.
Hi. When doing your data modeling, are there special considerations when you're going to be storing binary data up to, say, 5 megs in a column?
You can, and that's where I always say compress if you can. And so if you, actually I have worked with people that are doing that. Large log files or something like that, or even images. There's plenty of use cases. The thing you have to consider whenever you put something large in a column value is the wire cost, or how long it takes to get something over the wire. If you put something 2 meg in a column value, just based on the speed of Ethernet, you don't expect that in 10 milliseconds. It's not going to get there that fast. But that may be okay for your application. Maybe you have a larger SLA. So that's really the biggest consideration. And then again, how many columns you have, you may get to a large, a physically large column, like a lot of megabytes, that will generate a different type of compaction, but it's more tuning. And that may not be a problem either, especially if it's somewhat like cold storage, so to speak. We always look, and again, back to our application. What is the important thing here? If your SLA is the most important thing, like I have to have every read come into 20 milliseconds, 30 milliseconds, okay, let's tune for that. If I need to be able to write 100,000 per second of this, but I don't care how fast I read it out, completely different story. That's why we're thinking about our application first and not our data. The relational way was, I got a lot of data. How can I dice this up? I got a bunch of normal forms. So that was thinking it from the data standpoint. So, I kind of gave you the bigger answer on that. I hope that helped.
Hey, Patrick. I was wondering about the future support for native SQL 3 in Solr and Hive, and how soon do you expect that to be mature?
Here's $5 for answering that. Thanks, Mac. Yeah, that'll be in a couple weeks. So DataStax Enterprise, which has Hadoop and Solr, this has been one thing that our DataStax Enterprise team has been working on very hard. Really what we're talking about is Cassandra 1.2, which has a lot of great features. Virtual nodes, it has the CQL native transport. Those are 2 very good reasons to be on it, but DataStax Enterprise is using version 1.1. To get to version 1.2, we had to make Solr and Hive be okay with using things like virtual nodes, and so that's pretty much done. So that'll be out pretty soon, and you'll probably have it before you know it, and I'm happy to say that. So DSE team, you rock. Thank you very much. So luckily it's not, I don't know. Any more questions? More. Uh-oh. Patricia doesn't get to ask questions. All right, fine.
Oh, thanks. So I had a question about size-constrained columns or size-constrained rows. So I know it's not practical to constrain your rows based on a set number of columns, because then you have to do the full read for each row every single time you do a write. But could you have a use case where you set a counter column for each row and then check that counter column only and sort of go through and do a hack constraint that way?
I think you just answered that. You said the hack word? No, I wouldn't do it that way, because all right, there's your read before the write, okay? You have to read the column value and then do a write, or yeah, you'd have to do a write, or even do another read with that. So you're asking like if the column count is say 10,000 or 1,000,000 or something like that, what would be the constraint? What are you worried about in that case? Like having too many columns and having a good count?
Just having too many columns, just keeping the size of the data to a certain size.
Well, you're not, all right, so if you're worried about that from the beginning, I would say that we would need to consider the data model as that's the problem. I don't want to have too many. So it's kind of a more advanced topic. There's more interesting ways to modulate how many columns you have by using the row key. And I would prefer to explore that until you ran out of it before you do anything with the word hack in it. You know, if you have the word hack in your solution, you're probably going to, that's going to come up in the next sprint because someone's going to say, you can't have a hack. So yeah, I would look at why you're even worried about that and address that problem from the beginning and just eliminate, because if you're creating a counter column for every time you put in a new column, then I really feel like that's an anti-pattern. And that's unfortunately the answer.
Thanks.
You're gonna follow up, aren't you? You are. All right. One more. Who's? You've already asked a question, but oh, there's one.
I was wondering if you had any.
Oh, you didn't ask a question. Sorry.
Any thoughts on, like, using sets and collections as primary keys in data modeling? Is that?
No. Creative. No. Yeah, I don't think you could do that. Wow, I've never done that. No, you cannot, because of the way that the collection is created, it would not work. But that's an interesting idea. Why would you want to do that?
It came up in a thought experiment with some friends.
Okay, that's an interesting.
So there were some artificial constraints, but.
See, all right, so let me try to go down that rat hole with you for a second. If you're creating a dynamic data structure as your unique key, that may not be the best idea.
Right, well, the idea is that it would be, you would create it and then it would be immutable, and then that you would use that immutable set as your primary key.
If you're creating an immutable set, then just create the right data model in the first place.
Okay.
I mean, I'm not trying to be harsh, but I mean, I'm just saying that's one of those things where we sit there and talk about it, because if you really say this is immutable or I have fixed fields, then you don't need a dynamic data structure.
Sure.
Yep.
Sure.
Okay. All right. I'll be over here.